If you seek peace, if you seek prosperity for the Soviet Union and Eastern Europe, if you seek liberalization, come here to this gate. Mr. Gorbachev, open this gate. Mr. Gorbachev, tear down this wall.
February 1992. On land, the history books were being closed with a satisfied thump. The Cold War was officially dead. The Soviet Union had dissolved just 6 weeks earlier, taking its last breath on Christmas Day, 1991. The world was drunk on peace. They called it the end of history. Americans believed the threat had evaporated. They believed the Russian bear was dead, buried under the rubble of its own collapsed economy.
By the grace of God, America won the Cold War.
But underwater, the war hadn't stopped. It hadn't even blinked. Deep beneath the ice of the Arctic Circle, the nuclear game of cat and mouse was still being played with lethal intensity. The crews didn't get the memo that peace had broken out. On February 11th, 1992, two of the deadliest machines ever built were hunting each other in the pitch-black water off Kildin Island. One was American, the USS Baton Rouge, a Los Angeles-class hunter-killer, the sleek black shark of the U.S. Navy. The other was Russian, the K-276 Kostroma, a Sierra-class interceptor, a rare beast forged from Soviet titanium. They were about to participate in an unplanned billion-dollar experiment in material science. At approximately 8:16 p.m., physics took over. They collided. It wasn't a firefight, it was a car crash, a grinding, screeching metal-on-metal impact that would tear one ship open and leave the other with an unofficial kill mark painted on its tower. This is the story of the Kildin Island collision. It is the story of how a fender bender in the Arctic suggested that Soviet engineering was tougher than American steel. And it is the story of the spy mission that almost started World War III 6 weeks after the war was supposed to be over. Why was an American submarine sitting off the coast of Russia in 1992? It was part of a top-secret lineage of operations known as Holy Stone, later renamed Barnacle. For decades, American submarines had been playing a dangerous game. According to later disclosures, they were sometimes ordered to penetrate Soviet territorial waters, getting as close as 3 miles from the beach to steal secrets. The mission profile was technically insane. Some missions involved the legendary cable tap, where American subs would sit on the ocean floor, deploy divers, and install recording pods on the underwater communication cables connecting Soviet naval bases. But that wasn't the only game in town. There was the hull check. U.S. subs would sneak up underneath Soviet submarines to photograph their propellers and analyze their hull coatings. We are talking about 6,000-ton Leviathans maneuvering within 50 feet of each other in the dark. And then there was the voice print. The goal was to record the unique acoustic signature of Russian subs. Every submarine sounds different. A loose valve, a noisy pump, a specific propeller hum. If you record it, you can track that specific boat forever using the SOSUS network. The USS Baton Rouge, commanded by Commander Gordon Kramer, was on one of these intelligence-gathering missions. She was lurking just outside the entrance to the main Russian naval base at Severnomorsk. She was the gatekeeper. She was waiting for a target to come out to play. The Baton Rouge was a Los Angeles-class attack submarine, the 688. This was the backbone of the U.S. Navy, fast, quiet, and deadly. But from a material science perspective, it was conservative. The hull was built from HY-80 steel. HY-80 stands for High Yield 80,000 psi. It is a high-tensile alloy containing nickel, chromium, and molybdenum. It is tough, it is flexible, and crucially, it is easy to weld. This allowed the U.S. to mass-produce these submarines in shipyards like Newport News. But the 688 class has a structural vulnerability inherent to its design philosophy. It is a single hull design. Imagine a soda can. The pressure hull is the primary structural barrier. There is no significant outer casing to absorb impact, only a thin skin and the steel ribs on the inside. This design is efficient. It creates more internal space for the crew and weapons. It makes the ship lighter and faster. But in a collision, it is fragile. There is no deep crumple zone. If something hits the side of a Los Angeles-class sub, it impacts the pressure vessel almost directly. And on February 11th, the Baton Rouge was about to be hit by something much harder than steel. Meet the enemy, the K-276 Kostroma. NATO called it the Sierra class. If the Baton Rouge was a sports car, the Kostroma was a main battle tank. The Soviet engineers didn't use steel, they used titanium alloy. Titanium possesses a significantly higher strength-to-weight ratio than steel. This allowed Soviet designers to build a pressure hull that could dive deeper, over 2,000 feet. But more importantly, the Sierra class used a double-hull architecture. The Kostroma was a ship inside a ship. The inner pressure hull, where the crew lived, was wrapped inside a second, outer hull made of light titanium. Between the two hulls was a gap of 1 to 2 meters, filled with water and equipment. This gap acted as armor. It was a hydraulic shock absorber. Furthermore, the Kostroma was designed for the Arctic. Its sail, conning tower, was reinforced to allow it to surface through ice in an emergency. It wasn't an icebreaker per se, but the leading edge was built to take a beating. The sail was essentially a giant blunt titanium axe blade. So, the stage is set. In the red corner, a double-hulled titanium-armored tank. In the blue corner, a single-hulled steel-skinned Ferrari. And they're both swimming blind in the dark. Why couldn't they see each other? Both ships had multi-million-dollar sonar suites. They should have heard a pin drop from miles away. But the Barents Sea is an acoustic nightmare. It's shallow. At the collision site, the water was likely only about 200 feet deep. In deep water, sound travels in clean lines. In shallow water, sound bounces off the surface, waves, and the bottom, rocks. It creates a chaotic echo chamber called multipath interference. To make matters worse, there was a storm on the surface. The crashing waves created a blanket of background noise that blinded the sonar. Reconstructions suggest Commander Kramer on the Baton Rouge was at periscope depth, roughly 60 feet down, listening. Captain Igor Lokot on the Kostroma was running quiet, likely somewhat deeper. At roughly 8:16 p.m., Captain Lokot gave the order to surface, possibly for a communications check or a navigation fix. The Kostroma angled its bow up. It began to rise. Captain Lokot checked his sonar. Nothing. The baffles, the blind spot behind his own ship, seemed clear. He didn't know that the USS Baton Rouge was likely right above him, suspended in the gray noise of the storm. Submarine warfare is a game of geometry. And on February 11th, the geometry was fatal. Every submarine has a blind spot. It's called the baffles. Because the propeller is at the back, churning the water and creating cavitation noise, the sonar array in the nose cannot see directly behind the ship. It's a 60-degree cone of deafness. Standard procedure for surfacing is to clear the baffles. You turn the ship to let your side sonar check the blind spot. Captain Lokot performed the check, but he heard nothing. Why? Because the USS Baton Rouge wasn't just behind him. She was likely above him or sitting in the acoustic shadow generated by surface wave noise. The Kostroma was rising vertically. It was the perfect ambush setup turned into a disaster. The American boat was the ceiling, the Russian boat was the floor, and the floor was coming up fast.
Welcome to the edge of the impossible. This is Apex Engineering.
8:16 p.m. The collision wasn't a glancing blow. It was an uppercut. The Kostroma is a 9,000-ton vessel. It was rising at a slow ascent speed. When it hit, the reinforced titanium sail struck the Baton Rouge on the port side just aft of the sail. The physics of the collision were defined by material stiffness and geometry. The Kostroma's sail was a rigid titanium structure designed for ice impact. The Baton Rouge's hull was high-tensile steel plate, When they met, the titanium structure deformed far less than the steel. It distributed the load, essentially acting as a hammer striking a sheet of metal. The Kostroma violently displaced the American submarine, forcing it upward through the water column. For a split second, the two nuclear-powered leviathans were locked together in a metallic embrace. Then gravity took over. The Baton Rouge rolled violently to starboard. The Kostroma bounced off and plunged back down. Inside the Baton Rouge, the world ended. The crew didn't hear a bump. They felt an earthquake. In the galley, dishes shattered. In the control room, Commander Kramer grabbed the periscope stand to stay standing. The sound was the most terrifying part, a screaming screech of metal tearing against metal that lasted for several seconds. Panic set in instantly. Collision! Collision! Port side! The first thought wasn't Russian submarine, it was iceberg or bottom. But then came the realization. As the Baton Rouge stabilized, the sonar operators heard something chilling. They heard the distinct sound of another set of propellers speeding up. They heard the whine of a foreign turbine. Commander Kramer realized the truth. They hadn't hit a rock. They had been hit by a hunter. He ordered an emergency surface. "Blow all main ballast!" The Baton Rouge shot to the surface, the crew praying that the pressure hull hadn't been breached. If the steel had cracked, they would be dead in minutes. On the Kostroma, the experience was different. They were the hammer. The Baton Rouge was the anvil. Captain Lockett felt the ship shudder violently and stop its ascent. It was as if they had hit a concrete ceiling. His first thought, we hit the ice. But the depth gauge said roughly 20 meters, too deep for ice in this sector. Then the sonar operator screamed, "Hydro-acoustic contact, bearing 090, high-speed screw noise." Lockett realized he had just headbutted an intruder. He ordered battle stations. The Russian crew scrambled. They didn't know if the American sub was attacking. Was this the start of a war? Had they been rammed on purpose? Lockett surfaced the ship. He raised the periscope. Through the winter gloom and the storm spray, he saw it. A massive black shape, barely visible in the waves. The Baton Rouge. She was listing. She looked wounded. The Kostroma circled. Her titanium sail was smashed. The hydroacoustic sensors in the leading edge were crushed, but the pressure hull, intact. The double hull construction had done its job. The outer casing took the hit. The inner hull was untouched. The ship was safe. The Baton Rouge, the damage looked superficial at first, scratches, dents, but the reality was structural. The impact had compressed the single hull frame of the Baton Rouge. Unlike the elastic nature of the titanium structure, which absorbed the blow, the HY-80 steel had suffered plastic deformation. The ribs of the submarine were bent. The circular integrity of the pressure hull, which is essential for resisting deep-sea pressure, was compromised. The hull was no longer a perfect circle. It was an oval. And there was a smoking gun. Embedded in the jagged metal of the Kostroma's sail, the Russians found pieces of black rubber and ceramic, anechoic tiles. The Kostroma literally scraped the skin off the Baton Rouge. It was physical proof that the Americans had been right there. The morning after the collision, the Baton Rouge radioed the incident to ComSubland. In Washington, the reaction wasn't just concern, it was panic. The timing could not have been worse. Secretary of State James Baker was scheduled to meet Russian President Boris Yeltsin in just a few days. The agenda was peace. They were discussing nuclear disarmament, food aid, and the New World Order. And now the U.S. Navy had to explain why they had just rammed a Russian nuclear submarine right on the edge of Russian territorial waters. The Pentagon did something unprecedented. Usually, the submarine force operates under the rule neither confirm nor deny, but the Kostroma was already broadcasting the incident on open channels. The Russians were furious. They were showing the dented sail on television. So the Pentagon broke silence. They admitted the collision, but they spun it. They claimed the Baton Rouge was in international waters, more than 12 miles out. The Russians claimed she was 5 miles inside their straight baseline border. It was a diplomatic mess. Yeltsin accused the U.S. of acting like cowboys. The Russian Navy demanded an apology. The Baton Rouge limped back to Norfolk, Virginia. It took weeks. When she arrived, the Navy put on a brave face. The official press release said there were some scratches, dents, and 2 minor cuts on her port ballast tank. It sounded like a fender bender. But when the dry dock pumped out the water, the truth was revealed. The collision hadn't just scratched the paint, it had traumatized the pressure hull. The impact of the 9,000-ton Russian sub had subjected the Baton Rouge to a massive lateral shock load. The single-hull design of the Los Angeles class relies on the perfect circularity of the pressure hull frames to resist deep-sea pressure. The collision had caused plastic deformation in the transverse ribs. The hull was slightly out of round. Even a deviation of a few millimeters creates stress concentrations that significantly reduce the crush depth. The Baton Rouge was alive, but she was crippled. Engineers realized that to fix her, they wouldn't just need to patch the hole. They would have to cut out massive sections of the pressure hull, reframe the ship, and re-weld it with HY-80 steel. The bill would be hundreds of millions of dollars. In 1992, the Cold War was over. The U.S. defense budget was being slashed. This was the era of the peace dividend. The Navy looked at the numbers, and they were ugly. The Baton Rouge was 15 years old. She was halfway through her life. She was also due for a nuclear refueling, a complex process that costs $200 to $300 million on its own. It wasn't that the ship couldn't be fixed, it was that it wouldn't pay to fix her. Add the collision repair costs to the refueling costs, and the price tag was astronomical. The Navy made a cold, calculated decision: scrap her. They declared the Baton Rouge a constructive total loss. On November 1, 1993, less than 2 years after the crash, the USS Baton Rouge was decommissioned. She became the very first Los Angeles-class submarine to be sent to the graveyard. She was towed to the Puget Sound Naval Shipyard. Workers with plasma torches cut through the HY-80 steel that had failed her. They sliced the ship into segments. The reactor compartment was buried in a trench in Hanford, Washington. The rest was melted down into razor blades. The collision, combined with the brutal economics of the 1990s, had killed her. Meanwhile, in Russia, the story was very different. The Kostroma pulled into the Nerpa shipyard on the Kola Peninsula. The damage was ugly. The front of the sail was smashed in. The sonar fairing was gone. But the engineers checked the pressure hull, the titanium heart of the ship. 0 damage. The double hull architecture had functioned exactly as designed. The outer light hull and the water-filled gap absorbed the kinetic energy of the impact. The inner pressure hull remained perfectly circular. The structural integrity of the submarine was 100%. The repair was simple. They cut away the damaged sections of the sail, the outer skin, and welded on new titanium plates. Repairs began on March 28, 1992. They were finished on June 29, 1992. 3 months. While the American boat was awaiting a death sentence, the Russian boat returned to operational service. The Kostroma didn't just survive, she thrived. The Russian crew knew exactly what had happened. They heard the news that the Baton Rouge was being scrapped. In the naval tradition, if you sink an enemy ship, you paint a victory mark on your tower. The Kostroma hadn't fired a torpedo, but she had taken an enemy capital ship off the board just as effectively as if she had. So the crew painted a kill mark. It was a red star with the number 1 inside it. The Russian sailors even had a joke about it. Their captain named Lokot, which means elbow, so they called the collision the elbow strike, a playful jab at how they nudged the Americans out of the way. It was an unofficial, cheeky, arrogant signal to the U.S. Navy. It said, "We survived, you didn't." When the Kostroma went back on patrol in the late 90s, NATO pilots would fly over her and photograph the star. It became a legend in the intelligence community. The steel sub was gone. The titanium sub was wearing its trophy. The collision strongly suggested one thing: titanium has superior survivability characteristics to steel in a collision scenario. In this specific head-to-head smash, the titanium double hull survived. The steel single hull died. So, why doesn't the U.S. Navy build titanium submarines today? Why are the modern Virginia-class and even the upcoming SSNX still made of steel? Because of economics. The Kostroma was a technological marvel, but it was an economic nightmare. To build it, the Soviets needed hermetically sealed shipyards flooded with argon gas. They needed workers in spacesuits. The cost was astronomical. The Soviet Union only managed to build 4 Sierra-class submarines. The United States, sticking with inferior HY-80 steel, built 62 Los Angeles-class submarines. This is the principle of strategic mass. The U.S. Navy accepted a lower individual hull strength in exchange for producibility. Steel allows for rapid welding in open air. It allows for modular construction. In a war of attrition, 62 good-enough submarines will destroy 4 invincible submarines. The Baton Rouge was expendable. The Kostroma was a unicorn. The collision was a tactical victory for Russia, but the fact that the U.S. could afford to scrap the Baton Rouge without blinking proved they had won the strategic war. But the collision did change history. Before February 1992, American subs were aggressive. They pushed into the 12-mile limit constantly. After the collision, while there was no formal treaty signed, the behavior changed. The diplomatic fallout between James Baker and Boris Yeltsin was real. The Russians made it clear, if you keep ramming us, we will start shooting. The U.S. Navy began to exercise informal restraint. Tactics became more cautious. The most provocative aspects of hull rubbing were scaled back. The Baton Rouge became a martyr for a safer ocean. Her sacrifice forced the 2 superpowers to acknowledge that the Cold War was over, preventing a future accident from turning into a nuclear exchange. And what of the victor? The K-276 Kostroma is technically still alive. She served in the Northern Fleet for another 30 years. Despite periodic rumors of upgrades, the reality is more mundane. There are no confirmed Kaliber missile modernizations for this hull. As of 2025, she is likely laid up or inactive, waiting for a refit budget that may never come. It outlived the Baton Rouge. It outlived the Soviet Union. It outlived the peace of the 1990s. The kill mark on her tower, the red star with the number 1, remains one of the only times in history a modern submarine has claimed a kill without firing a shot. The Kildin Island collision was the final battle of the Cold War. It was a physical contest between 2 philosophies: American steel, efficient, fast, disposable; Soviet titanium, expensive, tough, rare. The collision demonstrated that Soviet engineering, for all its economic flaws, produced some of the toughest machines on Earth. The Kostroma took the best shot the U.S. Navy could give it, a 6,000-ton body check, and shrugged it off. The Baton Rouge is now razor blades and a buried reactor core. The Kostroma is a silent monument to a fallen empire. Tactically, titanium survived. Strategically, steel won.